Hello, in this video we'll be working on Unit 5 homework problems 21 through 24. For number 21, a particle moves along the x-axis so that its position for time greater than 0 is given by the function p of t equals e to the 2t minus 5t. And the first thing we're going to do is find the values of p prime of 2 and then p double prime of 2 and explain what each value represents. P prime of 2, first we're going to find p prime of t, and then we'll substitute in the 2. So p prime of t is just the derivative of p. The derivative of e to the 2t is e to the 2t times 2. That's the chain rule part, minus 5. If p is our position function, then p prime represents our velocity function. So p prime of 2 is going to give us the velocity at time t equals 2. P prime of 2 would be 2 times e to the power 4 minus 5, which is approximately 104.196. So this is the velocity of the particle at time t equals 2. P double prime of t, I'll take the derivative of p prime. The derivative of 2e to the 2t is 2e to the 2t times 2, so 4e to the 2t. And then the derivative of negative 5 is just 0. P double prime of 2, we'll substitute 2 in for t. We get 4 times e to the power 4, which is approximately 218.393, and that gives us the acceleration of the particle at time t equals 2. Part B, based on the values we found in Part A, what can we conclude about the speed of the particle at t equals 2? If we think of p of t as being our original function, then our derivative at 2 is positive, and the second derivative is also positive. So the graph of our position is going to be increasing at an increasing rate. And if our position is increasing at an increasing rate, then we know that the particle is speeding up. So we can say the position is increasing at an increasing rate. Therefore, the particle, we can say the particle's speed is increasing. Part C, on what intervals of t is the particle moving to the left, and on what intervals is it moving to the right? So to answer this, we want to know when our velocity, p prime, is positive and when it's negative. So let's enter our velocity equation. That's our p prime equation. 2e to the 2t minus 5. And I'll just try a standard window. Now this is the graph of my velocity. So it starts out negative below the x-axis, and then somewhere between 0 and 1, it crosses the x-axis and becomes positive. So in order to figure out where the particle is moving to the left, we want to know where the velocity is negative. So I want to find that x-intercept value. And let me try zoom forward to just get a little bit better picture here. So I want to find where this 0 is, and there's a couple ways I can do that. You can do second trace and use 0, like so, and we get a 0 at about 0.458. 0.458. So let me go back to my standard window here. 0.458 is where the velocity changes from negative to positive. So it's negative up until that point, and then it's positive after that point. So the particle is moving left. on the interval from negative infinity to 0.458. And moving right on the interval from 0.458 to infinity. And I need to justify that, so let me just kind of add that in here. Moving left on the interval from negative infinity to 0.458 since v is less than 0. And moving right on the interval from 0.458 to infinity since v is greater than 0. Part D, does the particle ever change direction? Well, the particle changes direction when the velocity changes sign. So we just saw on the graph that that happened at 0.458. The velocity was negative up until that point and then positive thereafter. So the particle was moving left until time 0.458, and then it turns, changes direction, and starts moving to the right. So yes, at t equals 0.458, since v changes sign. Number 22, the position of a particle is given by the function p of t. T is greater than 0. What is the average velocity from 1 to 3? Find an equation for the velocity, and then for what values of t will the velocity equal 0? Part A, what is the average velocity? So the formula for average velocity, it's the change in position over the change in time. On the interval from 1 to 3, then we want p of 3 minus p of 1 over 3 minus 1. So let's enter our position equation. We've got 2t minus 3 times e to the power 2 minus t. For t greater than 0. So I'll change my window and start my x-min at 0. Now I want to find p of 3. So I'm going to go into F4. Since I have my position equation in y1, I'm going to go into F4, so alpha trace, and then choose y1 of 3 minus, and now I want y1 of 1. So I'll go back into F4, y1 of 1. So that's my change in position, and I'm going to divide that by my change in time. And I get 1.911. So average velocity on that time interval about 1.911, and we don't know units for this problem, so I will leave the units off. Find an equation for the velocity, v of t. Well, that's going to be my derivative of position. So p prime of t, or we can just call it v of t. It's going to be the derivative. I need to use the product rule. So derivative of the first is just 2 times the second, e to the 2 minus t, plus the first, 2t minus 3, times the derivative of the second, which is e to the 2 minus t, times the derivative of 2 minus t, which is negative 1. Now let's simplify that a little bit. I've got 2e to the 2 minus t minus 2t minus 3 e to the 2 minus t, and I can factor out e to the 2 minus t, leaving behind 2 minus 2t minus 3, and then I can distribute my negative there. So 2 minus 2t plus 3, the 2 plus 3 is going to be 5 minus 2t. So that is my velocity equation. For what values of t will the velocity equal 0? If I set this velocity equation equal to 0, then I have a factored equation equal to 0. I can just set each factor equal to 0. And I don't need the calculator for this one because I know that e raised to a power will never equal 0. E raised to a power is always positive. So I don't have to worry about e to the 2 minus t. That's not going to cause this equation to equal 0. I just have to worry about the 5 minus 2t. So if we set 5 minus 2t equal to 0, so this is part C, and solve, we get 5 equals 2t, or t equals 5 over 2. Number 23, the graph of v of t, the velocity, is given below. So this is the graph of our velocity function. What conclusions can we make about the movement of the particle along the x-axis and the acceleration of the particle for time t greater than 0? Give reasons for your answers. So our velocity graph starts out negative. It's negative, 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 negative until we hit 2. Then it's equal to 0 at 2, and after that the velocity graph is positive. So what conclusions can we draw there? Well, whenever the velocity is negative, our particle is moving left. And when the velocity is positive, our particle is moving right, assuming that this is horizontal motion. We also have the fact that our velocity is increasing, and it's increasing the entire time. So if our velocity is increasing, we know our acceleration is positive. And that can help us determine something about our speed, which we'll talk more about in our next lesson. So for right now, we can say the particle is moving left on the interval from 0 to 2. It is at rest at t equals 2, then moving right on the interval from 2 to infinity. And once again, I forgot to justify. So let's put that, yeah, that's important. We need to put that in there. So the particle is moving left on the interval from 0 to 2 since v is less than 0. It's at rest at time t equals 2 since v is equal to 0. And then it's moving right on the interval from 2 to infinity since v is greater than 0. Now, since our velocity equation is increasing the entire time, we can also say the acceleration is positive. So it's positive on our entire interval. So 0 to infinity. And after the next lesson, we'll be able to describe whether the particle is speeding up or slowing down. And for that, we're going to compare our velocity and acceleration to see if they're both positive, both negative, or if they have opposite signs. And just to give you a little sneak peek, we can say that here in the graph, because the velocity is negative but the acceleration is positive, the particle is actually slowing down. The speed is decreasing. But on this interval here, so from 2 to infinity, the velocity is positive and the acceleration is positive. And if they're both positive, then the particle is speeding up, or we can say the speed is increasing. Number 24, a test plane flies in a straight line with positive velocity v of t in miles per hour, in miles per minute, at time t minutes, where v is a differentiable function of g. Selected values of v for times between 0 and 40 are shown in the table below. Find the average acceleration on the interval from 5 to 20 and express your answer using correct units of measure. So average acceleration is going to be the change in velocity. So we want v of 20 minus v of 5 over 20 minus 5. Change in velocity over change in time gives us average acceleration. those values we can read right from the table. V of 20 is 4.5, V of 5 is 9.2, and 20 minus 5 is 15. So that's going to be negative 4.7 over 15, or negative 0.313 approximately. And the velocity is measured in miles per minute. So here in our numerator, our units are miles per minute, and we're dividing that by change in time, which is measured in minutes, so it's miles per minute, or miles per minute squared. Part B, based on the values in the table, on what intervals is the acceleration of the plane guaranteed to equal 0 on the open interval from 0 to 40? Well, the acceleration is the derivative of the velocity. So by asking where the acceleration is guaranteed to equal 0, we're asking where v prime will equal 0. So that sounds like Rolle's theorem. Is there guaranteed a place where the derivative of something is going to equal 0? Conditions for Rolle's theorem are that our function is continuous. Is our velocity function continuous? Well, if we look back in our problem, it tells us that the velocity is a differentiable function. And if it's differentiable, it's automatically continuous. So yes, v is continuous, and it doesn't specify an interval, it just says that it's differentiable, which means it's differentiable everywhere. So v is continuous everywhere. It's continuous on our closed interval, 0 to 40, and v is differentiable on the open interval from 0 to 40. And now for Rolle's theorem, we have that third condition, that the y-coordinates at our endpoints have to be equal. And if we look at the y-coordinates at 0, we see the velocity is 7. At 40, it's 7.3. Those are not equal. So that does not meet the conditions for Rolle's theorem. However, if we look within the table, there are some places where the y-coordinates are the same. For example, at 0 and 15, we have y-coordinates of 7. And since our velocity is continuous and differentiable on the interval from 0 to 15, and the y-coordinates are the same, then we know somewhere between 0 and 15, v prime will equal 0. And that's not the only place, because we also have repeated y values here between 25 and 30. So that's another place where we're guaranteed that the velocity will equal 0. So I jumped the gun a little bit here. I didn't quite find the right interval to use for Rolle's theorem. But we can say yes. I mean, the question is basically answering, it's asking on what intervals is the acceleration guaranteed to equal 0. So guaranteed on the interval from 0 to 15 and on the interval from 25 to 30. Okay, so let's just say since v is continuous on 0 to 15 and differentiable on the open interval from 0 to 15, and v of 0 is equal to v of 15, then a of t will equal 0 somewhere on the open interval from 0 to 15. Likewise, we can say something similar for the interval from 25 to 30. Since v is continuous on the interval from 25 to 30, the closed interval from 25 to 30, and differentiable on the open interval from 25 to 30, and v of 25 is equal to v of 30, then a of t will equal 0 for some c on the interval 25 to 30. Part C, does the data represent velocity values of the plane moving away from its point of origin or returning to its point of origin? Give a reason for your answer. All of our velocity values are positive. And if our values are positive, that means our particle is moving to the right, assuming that we're talking about horizontal motion. But moving to the right would mean moving away from the origin. Even if we were talking about vertical motion instead of horizontal motion, moving up, because a positive velocity in that case for vertical motion would mean moving up, is moving away from the origin. So since v is greater than 0 on the entire interval, the plane is moving away from its point of origin. And part D, the function f defined by f of t equals 6 plus cosine of t over 10 plus 3 sine 7t over 10 is used to model the velocity of the plane in miles per minute on the interval from 0 to 40. According to this model, what is the acceleration of the plane at t equals 23? What does this value indicate about the velocity at t equals 23? And then we're going to justify our answer indicating units of measure. If f of t is the velocity, then f prime of t is our acceleration. They're asking us to find what is the acceleration at a specific moment in time, at t equals 23. So we want to find f prime of 23. And if we want the derivative at a specific point, we can do this on the calculator using nderive, or Math 8. So I'm going to enter my velocity equation in y1. 6 plus cosine of t over 10 plus 3 times the sine of 7t over 10. And make sure you're in radian mode when we do this. So I have my equation entered. I'm going to go back to my home screen and use Math 8, which brings up my numerical derivative. So it's the derivative with respect to x of y1. Now I could type out the equation I want to take the derivative of, or I can simply call it by f1. So if I go into f4, I can get my y1, and I want the derivative at 23. So negative 2.015. Negative 2.015. And the acceleration is the change in velocity with respect to time. So velocity was miles per minute, and time is in minutes. That means acceleration is miles per minute, or miles per minute squared. What does this value indicate about our velocity? Well, since our acceleration is negative at this moment in time, it means our velocity is decreasing. So the velocity is decreasing at t equals 23 minutes. So the plane is moving away from its point of origin at a decreasing rate. We know the plane is therefore slowing down. We'll talk more about speed and distance traveled in our next lesson.